So welcome everybody. Today with us is William Bill Miller. He is an INCOSE member since 1993.
Yes.
I think he's the editor of the Inside magazine since 2015, if I remember right. And he for sure knows all the system engineering books, and he has it at home.
Yes.
We have proof of concept in this one.
I guess I waved books at you during the Zoom sessions or Team sessions.
Yes, we've seen them all. Now, Bill, thank you for taking the time to
Thank you for interviewing me.
talking about system engineering. So, looking back at your professional career, how was that linked to systems engineering?
Okay. So actually, I want to go back to university. As I'm classically trained as an electrical engineer in control systems and digital design. And my academic advisor, basically in his control systems classes, gave me a passion for systems engineering. And my first job out of university was at Bell Telephone Laboratories, and I selected an organization that was called Network Planning, but when you looked at the description, we were basically the system integrators for the Bell Telephone system. Across all the subdisciplines, and covered both proving in new technologies, doing economic studies of the technologies, overseeing developments, and on into deployment and through the life cycle of those technologies.
Cool. So this shows that we have to inspire the systems engineers at university, or maybe even
So
before.
I basically fell into it. So in a nutshell, I tell people I come from the control systems wing of systems engineering.
Over all these years, how did system engineering evolve from your perspective and from your experience?
Okay. So at Bell Labs, my mentors were the previous generation of systems engineers and had been active with the growth of the telephone, well, actually communications system, and they basically gave me a passion. And the system engineering was much more, the emphasis was much more on analytic studies, very quantitative, because you had to make decisions, and you don't make decisions based on, oh, it would feel good to do it this way. So you had to have hard information. In terms of what technologies and when, especially when is a new technology sufficiently mature, and also it had to be interoperable with a range of legacy technologies that went back many decades.
Okay. Cool. When you look at the challenges industry is facing today, what would you say is the most area where systems engineering can help today facing with these, coping with these challenges?
Right. So the issue is the tremendous exponential growth and scale of systems, that everything is connected to everything. So there may be subtle influences where you don't have a direct interface, but something happens somewhere and there's an influence that impacts the system. And we sometimes call them unintended consequences and things like that, or what's the term? Black swan event. When if you had thought things out ahead of time, maybe we would have less black swan events. Not that they completely go away. The third piece is the system engineers need to recognize that the world is not deterministic. There are uncertainties, and you have to engineer for those uncertainties. So what you do is you need to have rich contextual modeling of the ecosystems in which your systems are going to operate. And because you have those impacts of that ecosystem, and you cannot engineer things as if the world was deterministic. And so you have to understand probability, statistics, distributions, and you need to engineer out on the tails of the distributions. And now you can go so far at the tail that have something become uneconomic in terms of resiliency and protecting against things. So you have to find that balance in terms of how much resiliency for the money. And you, again, what becomes critical is understanding the needs and risk preferences of your stakeholders. Some stakeholders will be risk averse, others will be risk seeking, and you have to understand all of that.
Okay, cool. So INCOSE came up with the Vision 2035, I think a very inspiring document. So get this to read yourself. It's everywhere in the internet, you will find it. How does the vision help bringing forward systems engineering as a whole?
Yeah.
What are the positive things you can say?
Just to set some context, this is the third vision document that INCOSE has published. Back before 2010, not quite sure of the date of publication, I was secretary of INCOSE at the time, and we were working with a similar team that did this vision to produce a system engineering vision in that era. And we published it, and it was freely available to anybody and everybody. And then in 2015, we published a Vision 2025, and then just beginning last year. So when the FuSE initiative, Future System Engineering Initiative, actually started back at the International Workshop that INCOSE had in 2018. Knowing we'd be producing a new vision, let's start with the existing Vision 2025, and given some parameters like scale of systems in terms of economic growth, everything's connected to everything, and uncertainties, basically begin thinking through what do we need to be doing so that when the Vision 2035 is published, we're literally out of the gate engaged and have already been working things. So there was no real, and because we were given access to drafts of the vision and talked to the creators of the vision, we were not in the dark as to what was going to be in that vision. We had a strong sense of it, so we could begin thinking what kind of projects do we need to be doing, finding the resources, recruiting people to do those projects. INCOSE is a volunteer organization, so you cannot direct somebody to go do something. You have to convince them that it's something that they want to do, but in a volunteer way. Yeah.
So that, as you mentioned, the FuSE activities or future of system engineering activities within INCOSE are dating back quite some time already. But now it's an official program. You're the program manager of this initiative. There are 4 streams that should contribute. We have the roadmaps and vision. We have the foundations, methodology stream, and the application extension stream. So maybe a few words on where this program has to go and from your point of view.
The way I describe it is that systems engineering, as we know it today, actually has its roots in the 1920s, 1930s, 1940s, and the current instantiation probably up through the 1970s. And system engineering, in terms of foundations, practices, methods, procedures, tools, was fit for purpose for the systems of those eras. But again, with the exponential growth, interconnectivity, and uncertainty everywhere, that mold of how to go about system engineering is no longer fit for purpose. So we have to find a new mold. And I'll give you an example. Anybody that has had basic physics or certainly mechanical engineering, any engineering discipline has been exposed to the mechanical advantage one gets with a lever or a pulley. Metaphorically, we need to find those levers and pulleys that allow system engineers to be much more productive than the current methods and tools that we use today. Because with the scale of systems and all the other things I talked about, I don't see system engineers increasing exponentially to keep up with that exponential growth and all of the factors. So literally, we have to find new methods and tools that give the equivalent of mechanical advantage to the work we do. An example project that we've been working beginning back in 2018, is in the area of AI. So one of the concerns about AI is an AI machine produces something, but we don't understand why it does what it does. There's a term called explainable AI to get at that, but I'll go beyond that, how do we go about system engineering AI systems, or systems that have embedded AI and machine learning? At the same time, is there a way that we can leverage AI to help us do the systems engineering? So we have two terms, AI for SE and SE for AI, the former to give us advantage in terms of the engineering of those systems.
Yeah. So this sounds like a very exciting future,
Yes.
and way still to proceed.
Yeah. Well, by the way, I wanted to mention, you mentioned earlier about the 4 streams.
Yeah.
The 4 streams actually came out of a recognition of the projects that we have had ongoing since 2018, and clustering them. What came out of that clustering, the affinity, similarities, came out, resulted in the 4 streams. So it basically, in some sense, was an organic realization of the work that we had been doing, but as we scale the program to better manage those clusters, like foundations, methodologies, and so on.
So it was quite a consequence from what you've
Yes,
done
yes.
in the past, and now to proceed into
Yes.
into the future. When we look at the future, what are the key topics that you, as a program lead for the FuSE initiative, have, let's say,
Yeah.
for the upcoming year?
Yeah. One of the challenges in the vision itself, there's a roadmap, and there are 5 categories in the roadmap of research or competencies, research, tools and environment, processes, and applications. And so when you read the fine print, those are not independent of each other. There are interdependencies, but the vision does not provide a relationship model. And similarly, when with our streams, which by the way transcend those, it's not a one-for-one mapping. We have to have a relationship model among our streams. The streams are not independent silos. They need to have permeable boundaries that we need to be sharing back and forth. So there may be some advance in methods that, as we look at an advance in a method, okay, how does that relate to our foundations? Is there a foundation that we missed that this advantage? Certainly we look to the foundations to help drive methods, but it can be a two-way relationship. Or things happening in the application domain that cause new methods to be generated to meet that application, needs to be fed back to the methodologies stream and perhaps the foundations stream as well. Also, we have a big task in terms of educating the workforce, to improve the competencies, not just the existing competencies, but what new competencies are needed, and how do we make those happen with the workforce. Okay.
Cool, exciting year.
Yes.
We just finished the international workshop in Torrance. How's your personal summary from the workshop itself and for the few sessions we quite had?
Yeah.
Some, I think, engaged working sessions
Yes.
here in Torrance.
Yeah, I mentioned at the wrap-up I just did that you were with, that mentioned, like, for example, the foundation stream. The room that we were doing was not right-sized. Many more people showed up, and I joked with I've been joking that I was fearful that the fire marshals would show up and say, oh, you've exceeded the maximum occupancy of the room. And in fact, if there were officials in the hotel, they could tell from the decibel level of the noise in the room with people engaged in the activities, that there's a lot of people in there.
Yeah.
And but anyway, I was fearful that they would show up and remove people from that. So it was that level of energy. And again, when we've surveyed the people, they indicated that level of energy, and they're excited about it. I believe we've lit a spark in that. So looking forward to that. And also what we're doing is we're basically giving priority to FuSE that are INCOSE events, and we're creating a framework in which here's the broad things that we need to be working, and then engaging both individuals and working groups in INCOSE, and extending outside to our sister societies throughout the systems community to be engaged in this.
Yeah. I think there's.
Oh, by the way, one more thing. If we don't, we will be irrelevant as those technologies mature. And by the way, it's not just an individual technology. You have to look at the integration of new emerging technologies in materials, computing, biologics, algorithms, and so on. So you have to look at it holistically, and that if we're not addressing those things, we will be irrelevant.
Yeah. I think I liked what you said, that there's now a spark, and I think we have to get it going, to get the fire going,
Right.
with
So
all this
right,
FuSE
so-
initiative.
Right, so basically we'll be framing our events moving forward, but also for people that cannot be here in person, we will, and for those that were here, having a continuum of virtual events
Events.
between the major events that we hold in person on specific topics to get engagement, but also to gain knowledge.
Yeah, I think to engage the community inside INCOSE, but also to get some impulses from the SE world
Right.
outside to
Yes.
bring everything together, working towards the
Right.
future of system engineering.
We've had some limited, but we need to, as I said in the room, we need to up our game on that. By the way, another thing that gives us some inside track to do that is that for the SE Vision, we sent it out to review through our sister societies and in the systems community, and we got a good response to that. So you helped us review this. Can you help us we need you to help us realize this.
Okay, so thank you very much, Bill, for taking the time. I'm looking forward. Maybe we can do another interview in half a year, and maybe at the symposium.
Right. There'll be plenty to chat about as we go along this journey. So
To see where we are then.
Yeah, thank you, Stephan. Appreciate the time with us.
Thank you very much.
Thank you.